Okay, this is the revision sheet for the foundation mock exam. And the first topic area is P8, energy and forces doing work. Now, we did go over this in lesson. So you've got an electric motor transfers 1.3 kilojoules. So we're going to have to change that times 1,000, 1,300 joules. 4 minutes, times that by 60, 240 seconds, and it wants the power. So for that, we're going to need the... Oh my days. We're going to need the PET triangle, but it gives you the formula there, E equals P times T. So we can see here now, well, P equals E over T, we're after P. Back into here, so take the 1,300 divided by 240 equals 5.4 watts. Please make sure you learn that unit for power, watts. If you wanted to, you could use joules per second, or even joules seconds to the -1, but just remember your watts. Okay, so the next one now, motor transfers 1.3 kilojoules. So again, times that by 1,000, 1,300 joules into useful kinetic energy and 500 of wasted. So we're going to need efficient, useful tools. But the important part is it asks for the percentage efficiency. So at the end, we're going to have to times it by 100. And I've said to you, anytime they give you a percentage, change it to the decimal to use that in your calculation. So we can now see, well, we're going to work out the useful. So that's the total. That's the total, take away the wasted. Now we've got the useful is 800, and I just divide that by the total. So there's the formula, 800 over 1,300, and then times it by 100 to get the percent. And there we go, 61.5%. Next one. 240 grams, not happy with that, I want that in kilograms, 0.24 kilograms. Was lifted by a motor to a height of 1 meter 60, so we've got 1.6 meters. What is the total gravitational energy? So GP equals mgh. Clearly it doesn't tell us the value of G, so we're going to have to remember that's 10. So it's the 0.24 for the kilograms times gravity 10 times 1.6 meters, and we've got 3.84, and because it's energy, joules. Okay, next part, we've now got a moving car brakes to a standstill. So you can imagine I've got a little car here, it's moving, so it's got kinetic energy, and what I've got to do is get rid of that energy from the car, and that's going to go into the brakes, and they're going to get hot, so we're going to end up with thermal energy. And I said in lesson, just make sure you tell us what energies go increase, what energies decrease. So my first part is, well, the kinetic energy stores go down. We want the car to go from moving to stopping. Friction increases the thermal energy stores. So we've got to get this idea of there's friction in the brakes. Brakes are going to get hot, and therefore the thermal energy stores will increase. And then that heat energy will dissipate into the surroundings or into the air. Next one, students use a light gate and a data logger to measure the time. Why? Is this an improvement to using a manual stop clock? Well, with the stop clock, I've got a human pressing it. If I've got a human pressing it, I've got reaction times. But with a light gate and a data logger, I get rid of those. And what we're going to see is that reduce the error in the experiment. So the first part is removes human reaction times. And the next part is this reduces systematic error. So we've got systematic error is error that's built into the method. And then random error are just things due to different temperatures on the day and things like that. So we've made an improvement in the method, so it reduces systematic error. Next question, we've got to use the work equals force times distance. I've just gone over the formula. So I've taught you that as fat, wobbly dinosaurs. And it says boxes move with a force of 820 newtons. Perfect, that's in newtons. The person moving the box transfers 5.8 kilojoules. Okay, that's 5,800 joules. What is the total distance that the box has moved to 3 significant figures? So, bump. So we want to find out the distance, D. We can see we've got W divided by F. Next part, pull down your 5,800. You need to know that the energy is, so that's the chemical energy, is the same as work. So work and energy are the same thing, is what it's checking. So 5,800 divided by the force, 820, gives me 7.07. And we can see that's 3 significant figures. Your calculator will have a bigger number than that. And then the last one in this section, calculate the weight of 40 kilograms on Earth. Perfect, you're in kilograms, so I'm pretty happy with that. And for this one, whoops, we're going to need pens playing up my wrinkly gran. And again, it doesn't tell us the value for G because we want the weight. And you got to know that that's 10 newtons per kilogram. So weight equals mass times gravity. 40 times 10 equals 400. And we need to know that weight is a force. And that gets measured in newtons. I wish I'm going to have to fix my pen for the next one. And I think that's it. Yeah, that's that one done.